AltaView, analyzing spurious data on 1553 bus. 1553 bus messages that cannot be decoded into a valid message are called spurious data. This can be caused by bus collisions. Since 1553 is half duplex, only one terminal can be transmitting at a time, and collisions indicate an error condition. They could also indicate illegal communication or intrusion by a compromised terminal. Before we continue, be sure to check out our videos on cyber analysis and also on the general use of AltaView. I'll open a project using the AltaTVal MA4 product, which is a Thunderbolt 3 appliance. I have two 1553 channels open. Channel 1 is red and channel 2 is green. On channel 1, I have a simple bus controller schedule with one frame and 4 messages. The frame time is 10 milliseconds. I have created buffers for my messages. Message 0 is a BC to RT message to RT1, sending a data pattern starting with 1s. Message 2 is a BC to RT message to RT3, sending a data pattern starting with 3s. The other 2 messages are RT to BC messages. I am also simulating 4 remote terminals to provide responses to the bus controller. RT1 and 3 will be receiving data, and RT2 and 4 will be responding with data. RT2 will respond with a data pattern starting with 2s, and RT4 with a data pattern starting with 4s. I'll start the RTs, start the bus monitor, and start the bus controller, and you can see all bus traffic running smoothly. Green is good, and each message is occurring at the expected frequency of 100 Hz for our 10 millisecond frame rate. Snapshot Viewer shows the details of each message. You can see the BC sending RT1 the 1s pattern, RT2 sending the BC the 2s pattern, and so on. Now on channel 2, I set up a second bus controller that I'll use to simulate a compromised terminal. First, I'll use it to send messages to RT1 during dead bus time, using the same frame rate as bus controller 1. My buffer data consists of a C pattern. After I start the bus controller on channel 2, it does not cause any bus errors, but you can immediately see the detected message frequency increases for RT1 to something other than we would expect. Now let's change the frame rate to simulate a compromised terminal that is causing bus collisions. You can see errors appear on RT1, and spurious data is detected. With Snapshot Viewer, we can search for messages with errors, and we can see that the compromised terminal is causing bus collisions that are being detected as various errors, such as no responses, sync errors, and word count errors. With Snapshot Viewer, we can find each of these messages. Signal Viewer will give us some additional insight. First, let's trigger on any activity to see what a clean waveform looks like. Here you can see a series of data words. Signal integrity generally looks good with clean edges. Now let's trigger on any type of error and slide the waveform over. See the full amplitude signal coming from our bus controller, which is located on the same channel and same stub as our bus monitor. The lower amplitude signal is coming from another terminal on another stub, the compromised terminal. Since our bus monitor is on channel 1, signals originating from channel 2 have a lower amplitude. You can also see the point where the intrusion collides with valid data, and the poor signal integrity of the full amplitude signal due to bus contention. You can set up other triggers based on command, data, and status, and troubleshoot from there. So to summarize, the methods for analyzing spurious data are using the Discovery window to see message status and message frequency, Snapshot Viewer to search for errors and view data and timing, and Signal Viewer to trigger on errors and to examine signal amplitude and signal integrity. Want to know more? We're happy to help.